Hi, this video is on comparing the disk and the shell method. Um, so let's take a quick look at the next slide. The first two graphs are part of the disk method or showing the disk method. If you look at this first one, if we rotate around the y-axis, do you notice they're using y as the variable? Um, if you and in the disk method, once again, if you use x as the rotating axis, then you're using x as the variable. Also, in the disk method, the rectangle that you create is perpendicular to the axis of symmetry, or the axis of rotation, not symmetry. Do you see that rectangle rotates around the y-axis and it's perpendicular? Same way in the disk method, if we rotate around the x-axis, the rectangle that's formed is perpendicular to the x-axis. So that is the disk. The shell method, over here we have the shell. Here, if we rotate around the y-axis, we use the opposite variable. We use the x variable. And then if you rotate around the x-axis, we use the y variable. So there's a little difference there between the disk and the shell. If you look at the rectangle that's formed when we rotate around the y-axis, it's perpendicular. I mean, it's parallel to the y-axis. If we rotate around the x-axis, here's the x-axis, do you know it's also parallel? So these two are parallel to the axis of rotation. These two in the disk method were perpendicular. The rectangles are perpendicular to the axis of rotation. All right, so now I have an example where we're going to do both methods. And up here, it says the shell method is preferable for this particular problem. So here's the particular problem. We're going to be using the disk method right now. So first, we're using the disk method. And if you look at the disk method, you have to break, and we're going to rotate around the y-axis. You have to, since we're rotating around the y-axis, we have to use y as our variable. So we're going to integrate from 0 to 1 and then 1 to 2. Do you see there's two separate shapes here? Two separate shapes that we have. So you have to actually, when you use the disk method, you have to break this up into two separate pieces. So here's what they do. Once again, from 0 to 1, if you notice from 0 to 1, all you have is a rectangle there, length times width. And then from 1 to 2, you have the equation y equals x squared plus 1. So once again, and we're doing this to the y-axis. So y is our variable for the disk method. Once again, this is the disk method. I wish they wouldn't have posted shell up here. So we are using the disk method. If we rotate around the y axis, we're going to use y as our variable. And that's what they do here. You break it up into two pieces, 0 to 1 and 1 and 2. You can go through and verify that all this is correct. When we go through the answer, we end up with 3 pi over 2. So once again, that was the disk method. We had to break it up, this particular shape, into two pieces. Now, if we use the other method, the shell method, you don't have to break it up into two pieces for this particular problem. We're going to rotate around the y-axis. However, for the shell method, since when you rotate around the y-axis, we use x as our variable. So and here's the different the equation for the shell method that we should have went over when we did the shell method, and the disk method had a separate equation. So if you look at it, we're doing everything with respect to x, and it only requires one integration. So using the shell method only required one integration, and we get the same answer. So that's the main difference between shell and disk method, um, is is what variable you're using, and whether you have to break up the shapes into different pieces. In this particular method, the shell method, I think, might have been easier because you only had one integration. The disk method, we had to integrate twice. You had two separate shapes, so there's more room for error if you have to integrate twice. I hope this helped. This just compared the disk and the shell method for one specific problem. Let me know if this video helped you.